Welcome back to Hex and Cube map generation visual scripting using uNode Part 2. In Part 2 we are going to be adding a cube map functionality, adding some node specific information, and naming each tile on a list using the list type and string builder. So first what we want to do is start off with changing some of the models because didn't necessarily create them correctly. So we'll check that out here. We want to kind of center them, as well as updating the colors, and then we'll probably go ahead and export them. So here we want to export to an OBJ file. I find it to be easier to work with the actual models of ProBuilder. Sometimes for some reason they seem to lose reference to the mesh itself. And I find that this way it prevents it from losing the mesh. Also, as you drag and drop in the OBJ file, it puts it under a sub-object. Typically want to take that out of the sub-object and make it a prefab itself. I'm also going to colorize them, as I mentioned in the previous video, so that green, red, and blue are different objects. Here you can see that I'm just copying and pasting out the components. Obviously there's an easier way to do that. You could just drag and drop or unpackage the prefab and drag and drop the subcomponent into the hierarchy and then make a prefab out of that as well. So we're going to go ahead and start in the calculate world coordinates method. In this method we are going to start calculating how to set up the grid for a cube or a pointy hex or a flat top hex. Right click on the back canvas and go ahead and select if, and then drag in the is hex from the global variables and link the two. So if hex, then do something. And we will link this if true statement to the next if statement that already exists. Of course, to add a region, we're just going to go ahead and right click on the canvas itself and then select add region. Right now we're going to set up a couple of the x and z values if it's a cube or square. So we're going to go ahead and drag in the x and z local variables from the local variables list, and we're going to connect those to the false pin of the if statement above. So here we'll go ahead and set each of those, both the x and z, and we will link that to the pin of the the false pin of the if statement. Let's go ahead and add a region here and color it and notate it so it's the cube and square logic. This will help identify each section quickly and easily as we work through them. Okay, now we're going to go ahead and get the grid position. So we're going to go ahead and right click and type in grid position. Remember, this is the input parameter of the calculate world coordinates. We've defined that in the parameter section of the method itself. So go ahead and grab grid position, and it's a vector 3, so we're going to go ahead and find the vector 3.x. So in the drop-down menu you can easily type x, and it should be one of the first options at the top to select from. Then we'll go ahead and get the subtract node. So right click on the canvas and select or type in subtract and then select it. And we're going to subtract this from the grid height in tiles divided by 2. So go ahead and grab the grid height in tiles from the global variables list. And then we're going to divide this by the 2. And then we're going to drag that into the subtraction node that we already created. We're going to go ahead and multiply the results of this by tile width. So what we want to do is go ahead and right click on the background. Let me organize this so it's out of the way. There we go. Looks a little bit better that way. So we'll go ahead and grab in tile width from the global variables list, and then we're going to multiply that by the results of what we have above. And that will equal the set value of x. Now we're going to go ahead and set the value of z. So z equals, and then we're going to do similar math, but instead of grid height in tiles, this will be grid width in tiles, and instead of tile width, we're going to use tile height. So we need to go ahead and grab grid position, so we can go ahead and either right click and search for it, or just copy the existing one that's on the canvas already and paste it in there. We will get the z value, the vector 3 z value of that, and subtract that from the grid width in tiles divided by 2. Now we're going to multiply the results of this by tile height. So we're going to go ahead and grab a multiply, and then we're going to go ahead and link that, and then we'll pull in the tile height from the variables list, and then connect that into the z value. The last thing we're going to do here is we're going to go ahead and do a return. We're going to return the values. Since this method has a return type of vector 3, we're going to go ahead and return the x and z that we just set to a new vector 3. So we're going to go ahead and grab the return value, and then we're going to go ahead and do a new vector 3 float, which is identified in the drop-down list. Make sure you grab the right one. Sometimes I click too quickly and grab the wrong one, or usually the first one on the list. Just be aware that it may not be the first one on the list. There, now we have that. Then what we do is we're going to go ahead and get the x and z. Select get, and then link those. We'll go ahead and compile the code now, just to kind of see what the C# script generation looks like. Make sure that everything looks reasonable. I'll go ahead and unlock this, and then we'll go ahead and click on the game manager. We can go ahead and drag in and uncheck the is hex and drag in the square and make sure that our logic works. And there, it looks pretty good. That looks like a square map to me. Okay, the last portion of this tutorial will be renaming or naming the objects that we instantiated, and then adding those objects or tiles to a list. So go ahead and click on the create grid method or function. Right click on the canvas and type in object.name and select it from the list. Go ahead and grab the tile local variable, connect the tile local variable to the pin of the object.name. We should be able to set that value just like that. Then what we're going to do is the string portion of the set value. The icon represents a string. We're going to do a string builder so it names each of the X and Y tiles how we want them based on row and column. We also want to go ahead and just add another region here just so we can easily identify it, and this is the set tile name section. So to get the string builder, you just right click, add node, and type in string builder. You can also go ahead and just scroll down and kind of look for it. Select it from the list, and then we're going to just plug that string builder into the string pin of the set value. Now here we're going to add, again, this is for the X and Y axis or rows and columns. So we're going to go ahead and type in a name, so it's going to be like a tile, and then we'll have X, and then we'll have kind of a slash or a dash or something, and then we'll have a Y, and then the actual value of the asset. We get the values from the for each loop, so we can go ahead and link those together by dragging the index of the for loop down to the string 2 of the string builder, and the index of the top for loop, and drag that down to the string value of the string 5 value of the string builder. Last section of part 2, we're going to go ahead and add all of our tiles to a list, but we will need to create a new script or game tiles script which will be attached to each and every game tile. So we can go ahead and set this up. We can start to set it up to get the transform of this object, but what we're going to try and do is get all of the children of the game manager of type game tiles, and game tiles doesn't exist yet, so we'll have to create that script to be able to do this. So we're going to go ahead and create a for each loop, and so we will cycle through all the children of the game board looking for game tile objects and then adding them to a list. So we go ahead and right click on the canvas, find for each, drag it in, connect all of those together like so, and then what we need is a tiles variable which will be a list of game objects. So in the variables list, go ahead and push the plus button, and then this will pop up, and then what you'll want to do is type in list if it's not in the list already, and then you'll select it, and then it'll ask you what type of list you want, and you'll select game object and then click the select button. Double click on the variable to go ahead and rename it, and we're going to name this tiles. You can hover over the inspector area on the right hand side of the variable to make sure that the type is correct. It should be a list of game objects. Now we're going to go ahead and drag in the new list that we created. Right click on the canvas and select add node. Then what we're going to be looking for is list game object, and then we're going to do an add of type game object. So we need to type in list, it should be listed there, and then we select the add option of the list function. Next thing we're going to go ahead and do is add a counter here. I'm not sure we'll actually need it, but just in case, I'm going to go ahead and add a counter as a local variable, and then just set that counter of counter plus 1 equals counter. So we'll go ahead and do that. Just set that value, drag in the counter, and then add 1. so here's where we're going to need the game tiles script attached to the game tiles themselves. So we're going to have to go out and create a new game tiles script. So right click in the hierarchy, go to uNode, and click on this new C# component. Type in a namespace and make sure it inherits from mono behavior. You can go ahead and remove the update function. We won't need that, but go ahead and keep the start function. Once that's completely filled out, go ahead and click save and find a location, preferably in the same directory, to save it. Once it's saved, it should show up in the project. Then open it with the uNode editor by clicking on it in the project and clicking on the Open uNode Editor button. I've noticed that if you do the namespace after you do, or before you do the selection of inheriting from mono behavior, it doesn't come across when you save. So just make sure that you double check that the namespace is entered here. Also, you can go ahead and update the summary for a more better description. At least one function needs to be added. We already have the start function, so we can go ahead and compile it, and that's really all we need for now for the game tiles script. We can then go back to our game board manager script, and we can add in the namespaces that we want to use. And this is done by clicking on the name of this class or script itself in the top left corner, and then going over to the using namespaces and adding your custom namespace, whatever you have decided to use. Now that we've compiled both the game tiles script, which is mostly empty, and updated the game board script with the using namespace, we should be able to grab the game tiles options that we need. As you can probably tell, I do still have a little bit of challenges finding exactly what I need in the list, but in this particular case we want the component game object, and then we want to get GameTiles.GameObject, and then we're going to loop through those. So, and then we're going to add that to the list GameObjects.add. Now we'll go ahead and just add another region here, add each tile to the list kind of note so we know what this section is for. Later on, this section will probably go away and we'll probably create a new method for it after a little bit of refactoring, but for now this will get the job done. Now what we're going to do is open each of the model prefabs and add in the game tiles script that we've compiled, so it's there and that the game manager can see that as a valid script component. So open each of the models or prefabs and update each of the prefabs with the game tiles script. Once we've updated each of the prefabs with the game tiles script, we'll go ahead and push play and see how this works. We do want to make sure that we update hex is unchecked, and go ahead and click play. So the tile board looks fine. We have way too many tiles in our tile list, but notice everything is named correctly. So something's kind of going wonky. Yes, here it is. We've connected our string builder set value to our for loop, and that's incorrect. We actually need to click on the top for loop, the next pin, and connect that next pin to our for each loop in the add each tile to list section. We also need to remove the component.GameObject that was here. That's connected to our GameTiles.GameObject and the list.add, and remove it. That's not required, and it was probably causing us some additional issues. So notice I have the for each loop going directly into the GameTiles.GameObject, which goes into the list at .add. Now that we've made those two modifications, this should work. We'll go ahead and I changed the size to a 5x5 and ran it again, and now we have 25 game tiles. That ends part 2 of our tutorial. Thank you.